Good morning, sir. My name is Vivek Kumar and my registration number is 19 BCE 1850. And the topic of my presentation for digital assignment 2 is secure hash algorithm SHA-512. So moving on to the introduction, the secure hash algorithm is a family of cryptographic hash functions published by the National Institute of Standards and Technology, NIST, which is a short form, as US Federal Information Processing Standard, FIPS. It is sometimes referred to as Secure Hash Standard, SHS. Okay, moving on to SHA-0. It was published in 1993 and it is a 160-bit hash function. So it was withdrawn shortly after publication due to an undisclosed significant flaw and replaced by the significantly revised version SHA-1. So moving on to SHA-1, it was published in 1995 and it is 160-bit hash function based on MD5 algorithm designed by National Security Agency NSA to be a part of the digital signature algorithm. So cryptographic weaknesses were discovered in SHA-1 and the standard was no longer approved for most cryptographic uses after 2010. So now moving on to SHA-2. So it is published in 2001 and was wholly accepted by cryptographers in the year 2011. A family of two similar hash functions with different block sizes known as SHA-256. And now moving on to SHA-512. So they differ in word and size, and SHA-256 uses a 32-bit word, whereas SHA-512 uses 64-bit words. So moving on to SHA-512, talking more about it. So it is a secure hash algorithm which gives a 512-bit message digest, and the plain text is processed in terms of blocks. 50 plain text block size, 1024 bits. So total number of rounds is 80, which is 0 to 79, and each round is Qword 64-bit. Each round consists of a constant key, and the buffers are equal to 8 buffers, and each buffer size is 64-bit. So moving on to secure hash algorithm, authentication algorithm, and hash functions work similarly like math, only the difference is independent of keys. So in hash function, we apply the PT without keys, which produces fixed length output. So we append this fixed length output to the PT message and send to the receiver. So at the receiver's end, the receiver will apply same hash function which generates the fixed length value, and this generated fixed length value and appended fixed length value will be compared. So if the both generated and appended fixed length is equal, then the message received from perfect sender. That is, the sender is authenticated by the receiver. Also, the message is not modified during the transmission. So it shows authentication plus integrity. So moving on to the objective, how to generate this fixed length value. So hash algorithm, which generates hash code independent of keys, which is no keys used, no encryption and decryption. So depends on the size of the output, 128-bit SHA-1 and 256 SHA-256 and 512-bit is SHA-512. So we get 512-bit hash code and hash function of M, which is a hash 512-bit. In SHA-512, plain text is processed as block size, which is 1024 bits, and number of rounds or steps is 80. Each round Qword W generated from PT, which is equal to 64-bit. Each round contains constant K filled with random number and represented in hexadecimal format. So buffer used to store immediate results and also used to store output hash code. Each buffer size is equals to 64-bit. Totally, we required 512/64, which is 8 buffers. Output of first block will be input to the second block, and output of the second block will be input to the third block. Similarly, like chaining block. Output from the last block is the hash code. Just a minute. Yeah. For example, 6 blocks of PT. So 1, 2, 3, 4, 5, 6, and the output of the 6th block will be the hash code. So moving on to the steps. So first we'll pad the bits followed by zeros, which is 1 and then zeros. So the length of the PT is 128 bits, less than the multiple of 1024 bits. In the step 2, we'll represent the original PT in 128 bits. Then append the 128-bit representation of the original PT such that the length multiple of 1024 bits. So in the step 3, initialize the buffer, which is A, B, C, D, E, F, G, H, each of size 64 bits in hexadecimal format. And in step 4, we'll process each block of PT in 80 rounds or steps. Then moving on to step 5, output in buffers is hash code 512 length. So this is the block diagram message digest generation right here. So this is the message, and here you can see the 1024 bits and the functions and the hash code, which is 512 bits. So moving on to the message digest generation. So it is a plain text which contains of L bits, and padding is done with 1 followed by zeros and 128-bit representation. So length equals to n into 1024 minus 128. So all combination of these bits will get multiple of n into 1024 bits. And each block is processed with block size as 1024 bits. So this 1024 bits is given as input to a round function. In this round function, input is 4 called buffers. Buffers will be involved in the function, and the output of this function will be given as the input to the second block. So continue for each and every block, and the output of the last block is the hash code. So the processes in the round function will be, so there are actually 80 rounds, which I told before, from 0 to 79. For each round's input are keywords, which is generated from PT for each round. So first is we can see like W0, W1, 2, 3 until 79, and also the constant K0, K1, 2, 3 till 79, and buffers A, B, C, D, E, F, G, H, and there are 3 inputs for each and every round with 8 buffers. So word is generated from PT and the constants. And the output will be given as input to the next round, like round 1, round 2, round 3, and till round 79. So as you can see here, so SHA-512 processing of a single 1024-bit block diagram is shown here, in which message schedule is there right here. And these are the rounds till 79. And this is the constants, and this is the hash code. So moving on to the next thing. So after completion of the all the 79 rounds, the 4, that is the data present in the buffer, will be added to the output along with the round 79. So plus minus indicate addition modulo 2 power 64, which is 2 raised to the power 64. So fourth buffer value will be added to the round 79, and this value will be given as output to the next function, HIF. That is H1, this is given as input to the function for the second block of the PT message. Likewise, we also have to continue for all PT message. And now finally, 3 functions are given as input to the round constant with all the 8 buffers, and word and constant. Here constant is will be represented with hexadecimal, and word size is 64 bits. So how to generate this 1024 PT message to 80 words? For this, we use generator from W0 to W15. Word size is 64 bits. There are 16 words from 0 to 15, which is equals to 64 into 16, which is we get like 1024. So moving on to the next slide, complete PT will be processed for first to 15 words, and first 64 bits for W0, second 64 bit for W1, and so on. Last 64 bit of P2 is stored on W15. So now we use formula to calculate from W16 to W79, and now we are going to talk about how to generate the word for each round. For first 16 rounds, we needn't generate these words because we access the PT message as words in the first round. So we have to generate from 16 rounds. So this you can see here is the SHA-512 round function. And here is 1024 bits, and this is the message. And you can see here for W0 till W79, this is of 64 bits. So moving on to the next, here you can see the formula is written, which is Wt equals to omega 1 raised to the power 512 Wt minus 2 plus Wt minus 7 plus omega naught raised to the power 512 bracket open Wt minus so 15 bracket close plus omega t minus 16. So where omega, it is not omega, it is sigma here, my mistake. and this sigma raised to the power 512 not x equals to ROTR raised to power 1 bracket open x bracket close and XOR ROTR 8 power to 8 and uh, bracket open x bracket close and XOR and SHR raised to power 7 bracket open x bracket close and then sigma 1512 bracket open x bracket close equals to ROTR raised to power 19 bracket open x bracket open bracket close XOR ROTR raised to power 61 bracket open x bracket close XOR SHR raised to power 6 bracket open x bracket close ROTR raised to power n bracket open x bracket close equals to circular right shift rotation of the 64-bit argument x by n bits. So SHR raised to power n bracket open x bracket close equals to left shift of the 64-bit argument x by n bits with padding by zeros on the right. So plus equals to modulo addition modulo 2 raised to power 64. So sigma naught raised to power 512 bracket open x bracket close equals to circular right shift of 1 bit of the given word XOR with rotation with 8 bits of the given word XOR with left shift of 7 bits of the given word. Sigma raised to power 512 of 1 and bracket open x bracket close equals to rotation of 19 bits of the given word XOR with rotation with 61 bits of the given word. So XOR with the left shift of 6 bits of the given word. So moving on to the next slide. So by applying formula, we have to generate the words from 16 to 79. So we are using the PT from W0 to W50, and then we need to generate the word from W16 to W79. And T is less than equals to round number. So starting number of T is from 16 to 79. And now we are talking about the constants. So total is 29 columns and 4 rows. Total is like 80 constant. Using a random number generator, we get the constant and we use each constant in each round. Totally 80 constants are there. So as you can see, these are the constants here, and these are all the mixed from the letters and the numbers here, and in all the each rounds. And now I'm going to talk about more formulas, which is T1 equals to H plus CH bracket open E comma F comma G bracket close plus summation raised to power of from 1 to 512 E bracket close plus W T plus KT, and T2 will be equals to summation from 0 to 512 A bracket close plus MAJ bracket open A comma B comma C A bracket close. H is equals to G is equals to F is equals to E is equals to D plus T1, D equals to C, and C equals to B equals to A, and A is equals to T1 plus T2. So where T equals to step number and it is between 0 equals to less than T less than equals to 79, and CH bracket open E comma F comma G is equals to bracket open E and F bracket close XOR bracket open not E and G bracket close, the conditional function. So if E, then F as G. So MAJ bracket open A comma B comma C bracket close equals to bracket open A and B bracket close XOR bracket open A and C bracket close XOR bracket open B and C bracket close. The function is true only for the majority that 2 or 3 of the arguments are true. So summation from 0 to 512A is equals to ROTR raised to the power 28 bracket open A bracket close XOR ROTR raised to the power 34 bracket open A bracket close XOR ROTR raised to the power 39 bracket open A bracket close, and then summation from 1 to 512 E bracket close is equals to ROTR raised to the power 14 bracket open E bracket close XOR ROTR 18 E bracket XOR, and then ROTR 41 bracket open E bracket close, and ROTRN bracket open x bracket close equals to circular right shift rotation of the 64-bit argument x by n bits. So by applying formula, we have to generate the words from 16 to 79, and we are using the PT from W0 to W15. And we need to generate the word from W16 to W79. T is less than equals to rounds. So starting number of T is from 16 to 79. So constant, totally 29 columns and 4 rows. So total is equals to 80 constant. And then we'll use a random number generator. We get the constants and we use the each constant in each round. So totally 80 constants are there. So as you can see here, this is the majority function, which tells, I'll read it out. It is like bracket open A, J and Bj, bracket close, XOR bracket open Bj and Cj, bracket close, XOR bracket open Cj and Aj, bracket close. And the conditional function is like bracket open Ej and Fj, bracket close, XOR bracket open not Ej and Gj, bracket close. And the rotate functions which you can see here is rotate A, which is ROT R28 bracket open A bracket close XOR ROT R34 bracket open A bracket close XOR ROT R29 bracket open A bracket close, and rotate E, which is ROT R28 bracket open E bracket close, and XOR, which is ROT R34 bracket open E bracket close, XOR ROT R29 bracket open E bracket close. So now moving on to this round function of SHA-512, the diagram you can see, this is all from A, B, C, D, E, F, G, H, and this is the major, and this is the like the summation, and this is like the 512 bits, and this is the WT and this is the KT. So all this thing can be seen in this diagram, and this is the final slide. So thank you for giving me this chance of the presentation. And so here I complete the topic 512, and thank you everyone.